Okay, today we're looking at single replacement reactions in activity series. Will the element replace the matching element in a compound? So let's first identify and remind ourselves what a single replacement reaction is. A single replacement reaction is a more reactive element replaces a less reactive element. Again, we recognize this because we have an element and compound on both sides of the arrow. So our notes are here. Let's write the definition of a single replacement reaction. I'll zoom in for you. A single replacement reaction, a more active element replaces a less active element. Okay? This is straight from our notes. So a single replacement reaction is a more active element replaces a less active element. A plus BC will give me AC plus B. Okay. So some of you have seen on the back of your periodic table this activity series that we had along with the polyatomic ions. You can use this one since it's bigger if you'd like. You just have to add the halogens to it. So we're going to predict the product of the following single replacement reactions. If the reaction will not take place, write NR. Do not write no, write NR. If the reaction will occur, we're going to write out the products using the word equations. We use the activity series. Okay, so let's look at our activity series. This is for what family? This is for the halogen family. Okay, group 7A. Halogens, as we know, are anions, which are negative. This activity series, and the one that's the same exact larger on your periodic table, this is the activity series for metals, which we know are cations. Okay? You will need to memorize the halogens. And we know that iodine is the less active, and fluorine is the most active halogen. Okay, and it looks just like that on our periodic table. That's why it's easy to remember. Fluorine, chlorine, bromine, iodine. Excuse me. Fluorine, chlorine, bromine, iodine. Easy stuff. Okay, so again, here are our metals and our halogens. So let's look. Chromium. Well, first of all, let's remind ourselves, using this stair step, anything to the left of the stair step are metals, and these are our cations. Anything to the right of the zigzag line, or the stair step, are our nonmetals, our anions. And remember, an ionic compound must have a metal and a nonmetal, or a cation and an anion. Okay? It can have more than a nonmetal because it could, of course, have a polyatomic. But ionic compounds must have a cation first and an anion second. Again, if I'm going too fast, make sure you pause the video so you can take notes. Chromium, is that a metal or a nonmetal? It's a metal, and it's a cation. Chloride is an anion. Iodine is an anion. So I have two negatives, so that means I'm going to look at the halogen list. So I always start with the element. The element is iodine. Is iodine more active than chlorine? No. So we write no reactions. Okay. Silver. Is silver cation or anion? It is a cation. Aluminum, cation. Phosphate, anion. Okay, so we're going to use our metals because we have two positives. So we always start with our element, which is silver, and put our finger on aluminum. Is silver more active than aluminum? No. So no reaction occurs. Okay, the third one, copper, is a cation. Sulfide, anion, and iron is a cation. So there's a couple of typos I need you to fill in. We need to write iron 2 here, because if you don't know what the charge of iron is, it's the transition metal. You can only know if you're being told. This should be lead 2 and, oops, that's why you're always supposed to write in pencil, right, Miss High? Okay. So, iron 2. Write those down. Just like when we did the moles, and I always gave you molar mass, I will always give you these even if you don't need them. Okay, so we're going to look at copper and iron. So put your finger on copper and your finger on iron. And we start with the element again. Is iron more active than copper? Yes. So it will be iron 2 sulfide plus copper. Your extra credit on your test will be to write this out in symbols. So Cu2S plus Fe yields Fes plus Cu. And you'll just need to balance it. So you're going to do that on your test. If you write out the equation, you'll have some extra bonus points for you. Okay, sodium is a cation, zinc, a cation, and acetate, an anion. So we're going to look at zinc and sodium. So put your finger on sodium and your finger on zinc. And we always start with the element first. Is sodium more active than zinc? Yes. So we're going to have sodium acetate, which is shrink wrap, plus zinc. Okay. All right, number 5, lead is a cation, chromium is a cation, and bromine is an anion. So again, we use the metals activity series. We put our finger on lead and we put our finger on chromium, which is, where did I see chromium? Right here. So is lead, because we always start with the element, is lead more active than chromium? No. So no reaction takes place. Lithium is a cation, manganese is a cation, and oxide is an anion. Okay, so we put our finger on lithium and we put our finger on magnesium. Is lithium more active than manganese? Because we always start with our element first. Lithium more active than manganese? Yes. So we write lithium oxide plus manganese. Now, if I write manganese plus lithium oxide, that's fine too, because 2 plus 3 is 3 plus 2. It doesn't matter. Calcium is a cation, chloride, anion, potassium, cation. So we put our finger on potassium and our finger on calcium. Is potassium, that element, is potassium more active than calcium? Yes. So we get potassium chloride plus calcium. Okay. Iron is our cation, sulfide is our anion, and magnesium is our cation. So we put our finger on iron and magnesium. Here's magnesium and here's iron. Always start with the element. Is magnesium more active than iron? Yes. So we're going to get iron plus magnesium sulfide. Okay. So now we're going to use, well, let's look at this. Silver is a cation, chloride is an anion, and fluorine is an anion. So we're going to use the halogen list. Again, starting with the element, let's put our finger on fluorine and chlorine. Fluorine is the element, chlorine was the compound. So is fluorine more active than chlorine? Yes. So it's going to be silver fluoride, remember everything ends in IDE, plus chlorine. Okay, got to change those endings. Remember, it can't be fluorine, chloride, or any of that kind of stuff, because two like charges never bond. They repel each other. Lead is our cation, iodine is our anion, bromine is our anion. So we put our finger on bromine and iodine. Here's bromine, here's iodine. We start with our element. Is bromine more active than iodine? Yes. So our reaction is lead 2 bromide, IDE, change that ending, plus iodine. Okay, so this was activity series. You're going to flip over on the back during class. We work these out, and we skip number 9, okay, the type of combustion.